Hi everybody, hello Unprompted. Really happy to be here. My name is Pete Smith. I am doing agentic things at Salesforce, product manager, engineer guy, all the above. And I'm joined by...
Hello everyone, I'm RK. I'm part of core team building AI SOC at Salesforce. Yeah.
Yes, the Agentic SOC. So we're here to talk about the Agentic SOC, and we've been working on some stuff. First slide demo, how do you like that? The Agentic SOC to us at Salesforce means a couple things, but mostly it means a collection of digital teammates working together where we are, and where we are is typically in Slack. So we want to show, we did show and are showing a demonstration of a bunch of agents doing stuff in Slack alongside a human where they're hunting, detecting, containing, collaborating, and everything in between. I see a lot of Mandiant people here. Who remembers when Kevin Mandy used to say, "It's the best day of my career"? Remember when he said that? Well, I feel like every day is the best day of my career at Salesforce because we get to work on this cool stuff. But what he also said is one day I want to have an app, a smartphone app, where I can go from alert to containment in 10 minutes. I'm happy to say that, Mr. Mandia, we have met and exceeded your expectations, sir. So we'll show how we not only take an intelligence report and synthesize it and pull out a bunch of IOCs, but how we also hunt across a large enterprise like Salesforce, contain hosts that are affected, deploy detections, and then bring in the human. So they're along the way and approving and making sure that everything the agent does is safe and sound. But enough talking about it, let's just show it. It's about a 4-minute demo, but we're gonna narrate it along the way and see how this goes. So here it goes. This is RK. RK and I were in a meeting with CrowdStrike on Monday, and CrowdStrike was telling us about a nasty nation-state-sponsored actor called Venomous Bear. So what does RK do? RK goes into the CrowdStrike, well, he goes into Slack, and he asks an agent to look up this Intel report. The report's number, if you want to follow along and you have a CrowdStrike subscription, is 2026035. If you look up that report in CrowdStrike, you're going to find Venomous Bear and about 8 IOCs, including domains and MD5 hashes that are bad guys. That's a real report. So yeah, we say demo data, but there's also some real stuff happening. So if you missed it, let's go big mode here. If you missed it, RK asks our agent in Slack, who we call Kestrel here, he says, "I just heard about this thing from CrowdStrike. What is it?" And so he sends this message in Slack, he's got this report number in it, and our agent knows what the format of a CrowdStrike report looks like in their intelligence portal, so we don't have to say, look up this CrowdStrike report. The agent says, it looks like 7 numbers, it's in this specific format, I'm gonna go fetch that. And the agent goes and does that. The first thing you're gonna see here, as Kestrel works on this, is a hunt task being created, which creates a Salesforce record for us. And in that hunt task, it captures all the data, the metadata about the hunt, including the report name and who launched it, in this case, RK here. This is when the fun begins. So now we've got like 9 other agents that are doing stuff while this hunt is being executed. And this all happens in our orchestration backend. And the fun part is, after we're done with the demo, we're gonna show you exactly how it all works. And you can take screenshots of the code and config, and you can do it yourself in 20 minutes from now. So stay tuned. But the first thing we queue up is this normalizer agent. So we have this pseudo-deterministic flow. I feel like determinism is all the rage these days in AI, so we've got some determinism in our AI system, and so we invoke this normalizer agent. It takes this report, it rips out all the IOCs, it takes a minute to do that, good stuff. And we're gonna move on to now this idea of a hunt planning agent. This is all happening in the same thread where we just asked to start an impact assessment on this CrowdStrike report. Cool, so the hunt planning agent looks at the IOCs, looks at the context of the report, and starts making up a plan for how he would hunt, or how he would hunt across our environment for these different IOCs. Very cool. So what does it do? It comes up with a, you could say, a hypothesis. This is what we know about the threat actor. This is what I found in the report. These are the data sources that I can consult, which have been redacted for yours and our benefit and our legal team's benefit. But generally, we're searching a SIM, and generally, we're searching our threat intel systems for evidence of these IOCs that our normalizer agent has passed on to our hunt planner to come up with this plan. So now we've got a plan that's proposed, but you see here the hunt plan must be approved. Is that big enough? Because I've got technology. Is that better? Cool. So we've got to plan this proof. We've got to approve this plan, and the way we do that is with our human-in-the-loop design. And so what you're going to see here is the system, the agent, asking RK if the plan to hunt for these indicators in our environment is sound. To do that, we have a couple things. First, we capture the business justification. RK is a pretty easy-go-lucky guy. He's going to say the plan is approved, plan looks good. And we capture the justification in our backend to not only inform memory for the next runs of this, but also as an audit trail for our regulators. And if you're in a large enterprise and you're doing things that mean like searching across environments or deploying detections or containing hosts, you're going to want to have the audit logging there. So we do. So we capture all that. Plan looks good. And then he's going to press that approve button. Thank you for your response, says our hunt planning agent. The hunt plan has been approved, and execution will begin shortly. We have another handoff here to another agent who, we see this hunt planning agent who locks the plan in place. We've made it read-only at this point, and we've got to pass this on to the one that's actually going to execute the hunt. In the meantime, we're thinking about a couple things happening in the back end. So that Salesforce record that we have is being continuously updated with the results of the hunt. But we bring in our IOC investigation agent, which is a agent that we have built, and we'll show you the agent card for what this looks like. The only thing this thing does is take an IOC and hunt across the data sources that we give it. It's deterministic in that we give it the data sources, the tools it can use to hunt, and the IOC. And we just say go. And there's a very clear and clean handoff before and after it begins. So the investigation agent goes and does its thing. It's starting the investigation. This guy is turbo impatient, so he's going to ping it. This might be the most realistic part of the demo when somebody asks if you're done already and it's been 6 minutes to hunt across an entire enterprise, but here we are. So he asks our Kestrel agent for the status, and the Kestrel agent is working. He checks the record, checks the status of the hunt tasks and what everybody's doing, summarizes it for the human. Great. That's like April 2025 stuff, not the fun stuff, but we did it too. And now we have our IOC investigation agent who's going into the environment, is actually searching for all of these different IOCs and preparing findings, which it will do. So we have another agent here. Actually, I think there's two that I missed. One is the findings review agent, which comes up with the verdict or whether or not it found the IOCs in the environment. Spoilers, it did. Also, it's not the Salesforce environment, but it's a demo environment. And then we have a hunt concluder agent. So after we've done the hunting with the IOC investigation agent for all the IOCs, we pass it on to the findings review agent to package it up into a nice report, to dump that in our Salesforce hunt object. And then we pass it on to the hunt concluder agent to say, wrap it all up in a nice little bow so you can pass it back to the human or figure out what to do next. Now, you'll notice we're like halfway through this demo. This is when it gets really fun. So somewhere here, yeah, not just good enough to find bad guys in the network, now we got to do something about it. This is fully autonomous remediation in play. So we're going to, the agent has proposed to us 3 recommended next steps. The first one is to deploy updated threat detection rules with our threat detection engineer agent. That's the agent who knows everything about how to deploy detection content in the Salesforce environment. The second agent is the remediation execution agent who executes remediations, block IOCs, contain endpoints, etc. And the third is the incident communication agent, where we might need to page an incident commander and say, uh-oh, bad guys are here, we got to do something about it. So this looks like a lot of not read-only, a lot of dangerous things to do in an enterprise. And of course, you need human in the loop for that too. So we prompt them with the business justification to say yes or not, yes or no, it's approved, and then we allow or deny it. This is all also very conversational to the point where RK could say, yeah, I don't like this plan, or I don't like what you're proposing to do this instead. And we have an agentic reasoning loop that'll go through those answers and feedback and propose better plan instead. But we like that, so we deployed the 3 specialist agents to go do these things. Threat detection engineer is writing IOCs, writing detections based on the IOCs. Then if I scroll all the way up here and maybe go a little bit back, you will see that we have done some video magic. Uh-oh. Hold on, technology. Okay. So we're going through, and now we have a list of the IOCs that we have recommended to write the detection rules for. We've done that detection, and now we're going to show the containment piece of that, and we're a CrowdStrike shop too, proudly at Salesforce. So the way we do containment is by passing in host names for which we would like to contain so we can continue our investigation. And so we invoke that here after the IOCs, and this is a synchronous process in the demo, but this can all be happening concurrently. It just confuses the output when you're talking to a human about this stuff. Each step along the way, this is the containment part. We're prompting the human for approval to do certain things, and we are moving on to the very end. The last piece in this is the incident communication agent who is now paging our incident commander, starting up a Slack channel, adding in all these agents so they can continue helping in the incident, and then bringing in some more humans to do actual investigation or the harder parts. And I said that was the last thing. That's not really the last thing. The last thing is when RK says, thanks, you've saved the day, agent friend of ours, digital teammate of ours, and the agent reciprocates and says, you're very welcome, happy to help, I never sleep, I'm always here for you, you're my best buddy, let's keep doing this forever and ever, and it's good times. So, 10 minutes, little under 10 minutes, alert to fix, to contain, to remediate, to all the other things. Not bad, Mr. Mandia, and even better, Salesforce team. Now, how does it all work, RK? Because I think this is what people probably want to know now. How did we go about building this thing? What does it look like? And what should folks take away from what we've done if you want to build your own agentic SOC in your enterprise?
I think this is the most critical slide over here. We have distilled all our learnings from building this entire agentic SOC in this one single slide. If you see, like, the block 1 and 4 acts as the cognitive layer of your agentic SOC. 2nd and 3 acts as the execution and orchestration layer of your agentic SOC. And 4 and 6 and 5 and 6 ensures that you don't end up breaking the production system. Lastly, 7 and 8 instills the engineering, design, and best practices in the agentic SOC. If you start to build an agentic SOC in your organization, you should start from all these core 8 primitives and then build your tech beneath them. Yeah. Next slide.
Everybody get that? Screenshots are good? Okay, cool. How about some architecture? And I'm going to zoom in on this one, and RK, walk us through the steps of the process they just saw, but now in an architecture view.
Yeah. So first thing first, we don't have to start from the scratch. What we did is, can you zoom out a little bit, Pete? Yeah. First we did is, we are using our existing security action library, which every organization has spent a lot of time in maturing and uplifting. Then we have system of records. So we are building an agentic layer, an intelligent layer, on top of this existing system. So if any vendor comes and says, oh, you have to re-envision your infrastructure again to build an agentic SOC, no, that's not true. We have built, the demo which you have seen is built on our existing infrastructure. We have just built a couple of modules on top of our source system, and that's it. So on the right side, you see our humans and digital teammates interact with the agentic SOC system through open-ended autonomous chains or deterministic orchestration layers. Depends on the workflow. So your workflow is pretty straightforward and like high risk, go with the deterministic orchestration route. If it is open-ended, like threat hunting for an anomalous threat actor, go with the open-ended autonomous chains. After this, the goal is taken up by the agent executor, which loads up the context using agent cards. We'll see each component in detail in upcoming slides. So it takes up the agent cards, state files, and goal files, and builds up the context. Once it builds the context, it uses LLM, all the foundational LLMs you have, for reason and planning. And then once it has to act on the different machines, it uses the capability executor. So capability executor just enables agentic LLMs to perform actions on our security action library, like to sim searches or pull threat vendor report or perform some action in an internal application or get a record from our system of records. While everything is happening, all the execution loops, all the critical components are saved under system of records for auditable purposes. So that's the entire high-level overview of agentic SOC. Just see, like, we are not using anything fancy MCP because it takes like a lot of time to build up the infrastructure and maintain it and all this stuff. I'm not against it, but you can build agentic SOC without having MCPs, without having A2As. Simple. Next. Okay, this you have to, yeah. This is the agent card. It defines the persona, the objective of a specific agent. Can you scroll up? Yeah. So you see over here in the top, you define what this agent is supposed to do, what kind of agent is this, and especially the configuration. So each agent is mapped to the individual workload of your agentic SOC. It helps prevent the scope creep and context drift. And on the configuration side, you see for each agent, based on the workflow that agent is supposed to complete, we have defined the models, the iterations, the temperature, maximum tokens, PII masking, and then on the allowed tool capabilities, we specify what tools this agent can utilize in the production system. And on just a piece on the max iterations, what is an iteration? Iteration doesn't mean a single LLM call, it means the full execution cycle. So you take the user input, you reason it, you plan it, you perform multiple tool executions, and then you send the prompt back, send the output back to the user. That's one maximum iteration. For every agentic system, every agent, we have defined maximum iterations. If it hits the maximum iteration, the governance layer, orchestrator layer exits the agent session gracefully, saves the entire state, and moves to the next layer. Okay. Yeah. This is tool config. It defines the schema of the tool, how LLM will actually utilize this tool. It also performs the integration. It also, yeah, thank you. It also ensures that what integrations are supposed to be invoked are known to the LLM agent, and then it abstracts the actual API calls which agent needs to perform from the LLM. So all the API keys, credentials are not exposed to the baseline LLM. And there, at the bottom, you'll see the permissions also. So at the agent card, you define what tools this agent can execute. Similarly, on the tool config, you define what agents are allowed to execute this tool. So we have permission check at the both ends. Next slide.
Just let everybody take it in.
Yeah. So agent executor, this actually manages the entire life cycle of your agent. It performs reasoning using LLM calls. It manages the context of the agent. It manages the state of the agent through multiple sessions. And when actual works needs to be done, like actual machine changes or system changes need to be done, it delegates the work to the capability executor, which is next. Slide, yes. So capability executor manages the actual execution of API calls on behalf of agent executor, on behalf of agents. And before executing, it validates the parameters, arguments, and then if human in the loop is required for critical phase changes or tool executions, it sends a notification to the humans in the channels they are in, and then only proceeds further if approval is provided. This is like an inventory, a catalog of our entire agentic capabilities or fleet, where we have all the agents, like what all agents we have, what all capabilities they have, and then once when a human provides an ask or an objective to digital teammates, agents, they scan this inventory. They understand for this workload, what all agents do I have available and what all capabilities they have. And then they intelligently select the agent and invoke that agent to perform the overall objective. So that's the routing piece over there. This is the third last slide. So this manages the state of the agent. It tracks, like if you see on the slide, on the config over here, we track the entire agent conversation. We track what objective was given to the agent, whether it was able to achieve the objective within the defined integrations. And then below it, you'll find like whether the phase was complete, all entire metadata of the session. And then we also track like tool level execution, where if agent is executing any tools, we track like which tool was invoked and what were the arguments provided and all the stuff. So yeah. This is the second half piece of the goal file. It is essential to build the trust within the system. We have to ensure that we expose we have non-repetition within the system. So we expose it by logging in who approved the tool calls, what were the reasons provided, and when it was approved. All the data is there so that we have full accountability of tool executions of risky tools. Right, next slide. Pete, do you want to cover this one?
20 seconds? Sure, why not? This is a incident lifecycle, you could say, and this is where we've embedded digital teammates along the way. Digital teammates are the first-class agents of our Agentic SOC. Digital teammates to us are the thinking, reasoning, planning teammates that we have. And so we like to treat them as part of the team. You can find them in our Slack channels, you can find them doing stuff, you can find them working with us. It's as if we take a grade 5, not a new hire, and start training them up. In 90 days, you've got a working agent. They learn from us, just like they would a human, and at every stage of the incident response lifecycle, you can find these teammates in the Agentic SOC. And honestly, it's pretty cool. So no, I think we're just about out of time. The takeaways, though, RK. So I think these are the things we've learned along the way. You've seen some of these over the last couple days, but deterministic orchestration, like I said, is kind of the rage. You don't want your LLMs going wild. The agent chains and chain of thought is cool, but keep it in guardrails. Don't have monolithic agents. We saw 9 agents, and you saw our agent card registry file had 600 lines. That's a lot of agents that we've defined in that thing. You should have a lot of agents, and they should be very focused and specialized to what they do. Always have humans in the loop, even especially while you're training these things, but this idea of a teammate means that they work with people, not always doing things on their behalf. This is ask mode, this is plan mode. Every IDE has this, your agents should too. Agent reasoning loops, this idea that you're never done with your first take of a plan, you got to keep iterating on it. So once you get that human feedback, you should use it, you should learn from it, and you should incorporate that into your next run. Use your existing infrastructure. RK talked about this, but we didn't tear down our SOAR, we didn't buy a new orchestration platform. We took our old SOAR, which has 257 different Python integrations. We taught agents to speak to it, and now we have agents that can do all the things that our SOAR could do, but reasoning and thinking through what to do instead of being defined in a workflow. And then let your agents earn trust using these workflows. Don't always agentify things that might have subpar outcomes. Use the 8 primitives we talked about. Have an AI constitution, which is a document that captures and codifies the rules for how you deliver an agentic SOC. Might look something like this if you're in Salesforce CSOC. Has different articles. One of those articles, in fact, the first article is the primitives that RK talked about first, because that's where you start. You start with those primitives, start building, follow your constitution, get everyone on board with it, and you're off to the races with the Agentic SOC, just like Salesforce. And I think that's our talk. Thanks, everybody. I think we'll take questions.
Hey, thanks for sharing. Really appreciate it. I think there are a lot of people that are watching this that are probably like working at AI agentic SOC companies that are furiously taking notes, so well played. Serious question though. What's your guesstimate on engineering person hours it took to develop this? And the corollary, what's the KTLO to maintain it? And then what are the costs of this infrastructure to run in dollar figures, not token numbers? And what is the corollary of those impacts on your KPIs?
I heard 4 questions there. I'm trying to think of which we can answer. Let's start with engineering time.
To be honest, the entire config, everything was written by Claude. I didn't write a single piece of code on this, though I have a good foundational knowledge of Python. So you need to know the basics and what do you want to build this. But otherwise, I didn't write a single piece of code over here for that. So
like zero time?
Obviously not the zero time, but I cannot quantify it right now, to be honest. So yeah.
No impact on KPIs?
KPIs, we measure them, we'll just say that. We should have had a slide that talked about the ways we measure the success of the agentic SOC, but the way we generally think about it is mean time to reduce or improve X, because those are our SOC performance metrics, and all we're trying to do is be better with the agentic SOC.
Cool. Yeah, so I imagine like KPIs are a proof point for whether it's worth it or not.
I think I'm required to say it is worth it, but I would also firmly believe that it is. I mean, I feel like I'd be in dangerous waters if I said it wasn't worth it at the AI conference. But we're just getting started with this stuff. I think, obviously, the tech is really hopeful. We are banking a lot on it at Salesforce, who talks about being an agentic enterprise. And we're off to the races in the SOC. Very compelling use cases. everything you just saw actually happens, if it's right and it can do it and it's quicker than a human, then it's a force for good and something we should be doing, yeah.
Thank you so much, Thrap.